Yeah, welcome everyone. Today it's our great pleasure to have our assistant professor, Professor Huang Chao, to give an update of his latest research. So Professor Huang is one of the rising stars of HKU IDS and the CDS. And he has many great projects, not only good citations, very well cited, over 14,000 times. So only a few years after PhD. And also his project got widely appreciated by the industry and also the research community, including over 77,000 GitHub stars, and also consistently ranked one of the mostly cited and top used packages in GitHub, the global top 200, and also making it to the GitHub training almost 60 times. So previously, Professor Huang shared with us his research on RAG and also auto agent. And today, he will be introducing more latest research, including like AI researcher, AI trainer, mini RAG, video RAG, and a few other exciting projects. So okay, so let's welcome Professor Huang to give us the talk.
Thanks for having me here, and I'm very happy to be here to deliver today's talk. Okay, so I'm Chao Huang, and from IDS and CDS at HKU. So today I would like to share with you, about our recent research exploration about AI agents, especially, its like a potential across different domains. Right. So first, I would like to introduce like 5 levels of the AGI. This has been proposed by OpenAI and Google. So first we have the a chatbot, probably it's like the first version, or the earlier version of the ChatGPT. You can chat with the AI, right? And then we have some reasoning models, like some DeepSeek and the old series of the GPT. And from beyond the reasoning, probably now we are enter the area of like the act, right? I think probably will be the agents. Yeah, because I think the agents will be a very good domains which can amplify the potential of the large language models across different domains, right? And then so probably will go from the agents to the innovation, and eventually we will achieve the manage, right? So that will be the the 5 levels of the AGI, and so now. Today's talk, we will focus on the agent level, right? And so because the agent probably will, I think most of you guys probably will use agent in your daily, work node. Probably to use agent for code to generate code, and use agent as a deep research, help you to do the deep survey and the literature review, and also you can use agent to help you to create some movies or short videos. So I think the agents might be adaptive and can handle and deal with like some dynamic knowledge across in the web. So that will be very impactful. And so we have achieved like probably finished some of our representative research works, right, from the RAG and to coding agent, and also on some trading agent, and probably recently we were working on some like AI core scientist, right? Because I believe the RAG and memory probably will be the foundation techniques for the AI agents. Okay. So here will be our GitHub repo. So all the content we deliver today are fully open sourced on our GitHub platform. So feel free to stop by our site and to explore our recent source code. And we are very welcome for your feedback and comments. And we will actively working on address your issues and PR, and to further improve and enhance our open sourced projects. Okay, so I think that for the agents, right? So nowadays, everyone talk about the agents, and many people say probably this year will be the year of the agents. But I would like to say probably agents they will take like a couple of years or even a decade to evolve, and it can be fully grounded from the LLM and 2 different domains. So I would like to probably summarize the agent into several key components, right? So first, the user may raise some request, and then the LM and the agents will do the planning. And then we have the memory, because the memory is take responsibility of just to how to do the context management. And then we have some agents can call some tools, can use the tools. And finally, the agent can help you to finish your task, right? And so based on the now the capacity of the agents, and we are working on some research and try to explore the potential of the agents across different domains. First, probably we are try to use and to propose some agent system and to generate some creative, to be your AI creator. Can help you to probably to generate some videos or to help you to edit some videos. That probably we can try to empower agents as your assistant as an artist. And then we are thinking about problem. Is that possible? We try to bring the benefits of the agents into the domain of the financial analysis, right? Because for the financial analysis, we take a lot of times, to do the deep research, to do the analyze, to do some problems will be the data science and works, and try to fully understand the trend of the financial. Okay, so is that possible? We can use agent and as a decision maker to empower the domain of the finance. And then we have the agent as an engineer, probably as a programmer or coder, right? Now, live coding has been widely, very popular among different programmers. And finally, we are thinking about problem because we are the researchers. Is that possible? So we leverage the AI as our core scientist to help us to do our research. Okay, so this talk probably will focus on these 4 dimensions and domains and to explore the potential of the AI agents, right? Okay, so the first, the AI, right? So probably I think very key dimension of the data will be that video data. Okay, so now we have the image. You can use Nano Banana to help you to generate some images from the text. We can have the text to image, but the video is probably will be just much more a richer compared with the image. Okay, so for AI for the video intelligence, probably we can just to summarize into 3 key dimensions. The first we have the video understanding, because you can input a video, and then you can chat with your videos, and you can probably try to grab some knowledge, key insights, and takeaways from your input videos. And then we can have the video editing, because sometimes you probably would like to edit and interact with your videos by input your requirement, and then you can have your expected videos. And eventually we have some a video generation, right? Like Sora 2, right? I think some people may play with a video generator and try to generate some videos. But I think for these domains, we are still face very key challenges for that. Okay, so first, that will bring the challenges for the agents. So we are doing the video intelligence where the agents are required to equip with the capacities with a multimodal understanding and multimodal analyze capacities. Okay, so that will bring the challenge of the agents. Now the agents is not only can understand and interact with the text content, but also can just to fully understand and interact with some multimodal content. So it's very challenge and difficult for the agents and especially for the large language models. Okay, so first to address the challenge of the video understanding, so we propose the frameworks of the video RAG, right? Because I think that nowadays we have so many videos online. I think it's impossible for human and to watch all the videos and you might be interested in. So it will be super cool if we can have the AI and to help you to summarize your interested videos. Probably and eventually the AI can generate a summarized video and into a short 10 minutes podcast or probably a 10 minutes short video and can probably deliver the summarized content to you. Okay, so by doing this, there is no need for you to go through and watch all the videos. Okay, so that will be, will be super cool. And so another thing is probably nowadays we have so many lecture recordings, right? So it might take much time if you just go through all the lecture recordings and to prepare your final exams, right? And so it might be helpful if you can input all the lecture recordings into the AI and also input your prompt requirement and outlines about how to prepare your final exam. And relevant problems will be the knowledge this course deliver. That will help you to save a lot of time, and you can focus on the how to understand the key insights from the videos. Okay, so that would be the motivations we propose the video rack and to address that challenge, the first challenge for the video understanding. But now, the limitation of the current AI techniques is there. It is very difficult to understand the extremely long videos. So it's possible for a current techniques to take less than 1 hour video as the input, and you can chat with the videos, but it's super long, it's super short. But actually, in our practical scenarios, we have extremely long videos. Probably will be more than 100 hours, right? So how to make the AI understand such extremely long context videos might be a very challenging problem. And so we tackle this challenge and propose our video rack system, and we also open source our demo, we call like a Vimo. Okay, so we propose the video rack and Vimo to enable the users and everyone can chat with your videos, right? So that's why purpose will be motivate us to design some key techniques relevant to how to build the index relevant to the multi-modal content and video data and how to do the retrieval parts. So it's actually straightforward and it's not very complicated. So we first to decompose the content. The content will be the multimodal content. It's a video content. So the modalities for the videos will be text, video, and also visual feature, and also the audio information. So how to build the index, which can fully be realized not only the text but also the audio and video information that will be necessary for for a video rack. So we first to generate and build the graph-based text index system, and which capture the text-based semantic information grabbed from the videos. And then we also to try to generate an index system which can be reflective of the visual features. Okay, so in this ways we have our two channels and the index systems which can be used to reflect not only the text but also the visual features relevant to these videos. Okay, so then if the user reads up the question, okay, so we try to match the question to the index system with the relevant content and also the relevant context, and try to do the fast and efficient retrieval. And then so you can have the knowledge which can just extracted from the video data. Okay, so that will be our frameworks of the video rack. And also we build a system for Vimo, and now everyone can download it from our GitHub repo. And so this will be very easy to use. And we also just to open source all the techniques relevant to our Vimo, and you can easily to interact with your videos and or to chat with your videos, right? And here will be our demo page.
State-of-the-art AI-powered video understanding platform with intelligent conversational capabilities and comprehensive video analysis. Ready to jump into Vimo?
Okay, so this will be our demo. And now the Vimo, you can upload your interested video and into the system. So now we have an example, and we just to upload the video of the OpenAI ChatGPT agent release a video.
For this walkthrough, we're using a great example.
So this video will be the release video relevant to the ChatGPT agent. So it's around half an hour. So the first, our Vimo system will build the index relevant to your upload videos data. Okay, so after we build the index system, and now then you can interact with the videos. Then you can raise up the question. Okay, so we just give the question, what is a ChatGPT agent? Right. So the ChatGPT agent has been released by OpenAI several months ago. So in order to have this answer, and there is no need for you to watch the whole videos. You can directly to grab the content relevant to your questions. And we can also just to translate the text content into some audio content. And then you can have your answers to be you can have your question to be answered with a podcast and audio and speech.
Let's challenge Vimo to
and we can also have a question, like a summarized question. Probably will be, give me a short summary of this video. Right. and then we can have a very, summarized information which can be delivered by the Vimeo
After a
system.
moment of
Here will be the
processing, Vimeo delivers
summarized
a perfectly
information.
articulated summary, proving it didn't just skim the content, it truly understood it. Vimeo isn't just
Okay,
capable
now
of
and
analyzing a
then
single
now
video.
we are also
It can tackle
suppose like
multiple
you can
videos without
upload
any
multiple
editing.
files, and
This
the
exciting
copies will be
demonstration,
not
we fed
for
it
like
OpenAI's
several
comprehensive Sora
hundred of
tutorial,
hours of the
which
videos.
spans 6 different videos.
Okay,
Then
so
we
and
challenged the
then you
video
can also just to
powerful
ask
questions.
any questions
What can I
relevant
use
to
Sora for?
a couple of
Please provide a
videos we
complete
have.
summary. The results? Absolutely impressive.
Okay,
By
so
diving
then we have
deeper
summarized
into the
information
video,
across
Vimeo
different videos.
accurately
So
identified
our
and summarized
videos,
Sora's
RAG
content.
systems, we try to build like
precision.
interdependency
Didn't just
information
watch the
across
video,
different
you
videos.
truly
So that will
comprehend
bring
it,
the challenges of the
extracting
current
the
techniques
essential features that
of
make
the
Sora
like a
such a
multimodal
groundbreaking tool.
language models.
We've prepared
Okay.
a super user-friendly.
So that will be the first dimension challenge will be the video understanding. And then we goes from the beyond the video understanding to the video generation. Okay, so we're thinking about problems. What might be the challenges of the current video generative models, right? So because now I think video generation is necessary and also can bring many benefits to our video intelligence domains. But what might be the key challenges? So the first challenges we have to say probably will be the current video generation models, like Sora and also the Veo models. They are probably will be limited to a long video generation. So for the Sora 2, probably we can generate short videos, last for 8 seconds. But now, probably I think in practical scenarios, we are thinking about it might be more useful if we can generate some long videos, right? So probably if we would like to express our ideas and also generate some more probably will be diverse and richer context. The video length probably will last for a couple of minutes and even for hours, right? So I think it brings very significant challenges for the current video generation techniques. So we are working on this direction, and we are trying to build a system relevant to the agentic video generation framework. So we release the Vmax, right? So in our Vmax system, we are trying to tackle several lines. So first, we would like to enable the idea to videos. So when the user can input your idea, and then we probably will deliver a fully added videos to you, which meets your expectations. And then we try to towards these lines and to enable the agents try to fully automated generate some short videos. So then you can only the input from the user side can be the only the input, the text, your requirement, right? And then the system can eventually can deliver a short videos, help you to probably to upload to social media, to some also TikTok, Red Note, and also can help you to do some to generate some videos relevant to some advertisement. So it's very useful across different domains. So that would be our vision. So we are trying to advance this research limit. So we built the Vmax. Okay. So for the Vmax, so the input actually will be the text-based input or audio-based input. So it's a text, right? So we have the text as an input. And our system try to, because we are the agentic system, so the Vmax will take care of all the different tasks. Like probably will be the director, will be the screenwriter and producer, and also eventually will be the video generator. But for the generated video, it's not only for the visual features. How to generate a video? For the video, actually, we have the audio, or we also have the video. We have some background music. So it's across modalities. So in this way, it is very challenging for only the foundation models to finish the task. So I think that will, just to have very fit the scope of the agents. Okay, so in this way, we build a multi-agent system with the agents and to be the director, screenwriter, and producer for that. Okay, so here will be the core components of the Vmax. Okay, so first we have the planning. So first, the only input from your side will be your ideas. So based on your idea, we will generate a story. So we will first to have a storyline based on your idea. So it's relevant to the components for the planning. Okay, so and then we have the screen, we have your story, and then we will how to schedule, how to take the shorts, right? And how to take the shorts which can fit your scenes and to meet your requirement. Okay, so for this part, we have the planning. Okay, and then we have the memory. For the agents, the memory will be the foundation for context management. But for the video, VMAX, video generation, the context is extremely long. So it is not only the text-based context, it's a multimodal context. So how to, for context, we have the character, we have the environment, and we also have some how to ensure the consistency across different time and the locations. So we have to keep the characters and the spatial locations and relationships consistent across different generations. So that is very important, necessary for the memory components. And also for the video generation, like how to make movies. So we have many tools. We can leverage the external tools which can benefit the video generation, especially for the long context video, because sometimes if you are target 10 minutes of the short videos, so we have to to leverage some tools which can further improve and edit your final generated videos. And then so we have different roles for agents, so it's like a multi-agent coordination systems. Okay, so that will be, so our VMAX actually is we have 6 stages for VMAX. So first we have the input idea, and then the agents will be, we have the screen agents and to write up the screens, and then we have some properties for the screen script planning. We have some tree-based plot refinement, and also we just try to generate some shoots and to do the shoot planning across different generations. And then for it goes to the generation stage, we have the text to image and image to videos. It's very similar as how to make movies. And how to make movies, we first to take some independent videos, and then we to do some editing and to do some cut, and based on your take videos. Okay, so that will be our VMAX architecture. And I think here's I would like to say for how to ensure the quality of the generated videos is also very important. I think that for our VMAX, so we design a component, we call it a judger, right? Properties will be, we design the agent which to evaluate the quality of the agents, because we would have to just to keep the high quality of the generated videos across different relationships and characters. Okay, so and finally we have our memory and to do the management and to relevant to the characters and the spatial relations and also different shoots. And finally, we deliver some, just to final generated videos. Okay, so here will be also some key designs relevant to how to ensure some visual consistency, right? And because I think the only input from users will be some text requirement. And we have some, to have some dependencies across different, tree-based plot refinement, and to try to, just to ensure the content consistent across different generations. Okay, so that would be the key designs of the videos of VMAX. Okay, so here will be some demos of the our generated videos relevant to the VMAX. Oh, is there any sound? Yeah. Okay. Okay, problems that will be. Okay, it seems like there is no sound for the videos. Okay. Yeah, so this is our student. So the student input his portrait, and then our VMAX generate short videos relevant to our student, and the properties will be last for different schemes, and also try to do some storytelling. So actually it's very smooth, but I think it will be the system, right? How to, okay. I think so it's possible, and so everyone can just to input your personal photo, and the AI agents can help you to generate a short video to you. and to meet your requirement for different, like across different schemes. So yeah. So this actually it's like short videos and short story relevant to our student. And probably I think the student can probably jump from the airplane and to the grounding and to do the landing parts. Okay. Yeah, and also okay, so yeah, it's probably I think. Yeah, we also generate some short videos and for some animals, right? Yeah. Okay, yeah. So all the videos all the video demos has been uploaded to our GitHub repo, and feel free to try to use our Vmax and to generate your videos and with your input. Okay. So actually, for each one is like a short story and relevant for different themes, right? Okay. Okay, so that will be our to explore the potential of the AI for some as a assistant for the artist. Okay, so next we are just to try to we try to explore the potential of the AI agents for finance, right? Okay, for some finance, we have the first application of the trading. We try to say, is that possible to have the AI to automatically to enable the trading and to make the decisions for trading? Okay, and then so we have the AI agents can do the automated financial analysis and relevant to different trend. Okay, so for the first of all, I would like to say that for the AI agents, the strong capacities of them will be doing the deep research. Okay, so for doing the deep research, so it means you probably the AI agents can help you to first to do the web search and the information summarization, and then help you to generate a comprehensive report and relevant to your topic. You would like to do the literature review. Okay, so that would be the capacity. So I think that's for the deep research. It is also very important for making the decisions for finance. Okay, so and also for the finance domains, the tool use is also very important, right? So we have to, just to leverage different tools relevant to finance. Probably will be some mathematical tools, and also some APIs we need to core and to do some data science analyze for relevant to financial data. Okay, and so with this objective, we launched the project, open source project for AI Trader. Okay, so actually we are trying to explore the potential of the AI agents and to check, can AI beat the market, right? So for this project, we have the three core contribution of the AI Trader. So first, we would like to build some benchmark of the AI evaluation and the capacity for the performance will be to be easily evaluated. I think that for the trading and also the stock market, it's very easy to evaluate the performance because we have some real time, some price we can check. Just to check the AI agents is up to make money or lose money, right? So it's very easy to just to evaluate. And then for the AI agents for the trading market, and so it's live. It's live means the environment is super dynamic. So it's super dynamic means we have so many factors which can affect the stock price. But I think the problem is a complicated problem for AI agents. So it's just to multi-role interaction beyond the deep research and also to some data analysis and then towards the final decision-making process. So that would be our core components of the AI Trader. Okay, so for the AI traders, now we launch three key markets. The first we have the US market, stock markets, and we target last stock 100, and we enable the different LM models and to compete in our live benchmark, and so then we also have the A shares and also cryptos. I think different market properties will deliver different performance for that. So for the AI traders, so the process is fully automated. So each decision is made by the AI itself, Right. So, and we also, just is a pure like tool-driven architecture, means that we have we have 200 tools. We have our tool set, and the AIs, different AIs, feel free to call different tools and to make the decisions. So it's a fully dynamic, but also automated, just process for the AI to make the trading process. Okay, so, and then here will be our results. Okay, so till last Friday, so we can check, so here will be the market for the US market. So we can check so now we have like 7 models compete. We have Minimax, we have DeepSeek, we have Gemini, we have Crowd, we have Chen1, we also have GPT. And in order to, just to reflect the performance of the AI capacities, we will also add the baseline of the QQQ. So the QQQ is ETF. So ETF, we consider probably will be like some human capacities, because it's an ETF. So the QQQ takes average of the probably will be the Nasdaq 100. Okay, so we consider it as a baseline. Okay, so now you can check different models. We have a different rank, but it's a fully dynamic. So this project is like a live benchmark. So everyone can watch the live show of the AI and to make decisions and how to where to when to sell, to buy the stock, and when to sell the stock. So it's fully determined by the AI. Okay, so you can check, and we have our assistants, and for each transaction, and so for each trade, so we also enable the display of its the reasons and also the reasoning results of the different AIs why why the DeepSeek will sell the stocks at this price, and how the DeepSeek, how the AI, how the agent think about, okay, how the AI can reason, okay, so when might be appropriate or best times to do the trade, right? So that will be fully dynamic, okay. But I think for the A shares, it's a totally different observation, okay. So we can check that probably I think most of the AIs lose money at the A shares, different from the US market. So we believe probably I think that might be a little bit different because for the US market, I think one key important thing is probably the US market will be put more emphasis on the foundation of different companies. So it's a long-term investment. For the long-term investment, the deep research and the analyze may add some values. But for the A shares, so it might not be super long-term, just an investment. It's like probably it will be some emotional or short-term some decisions towards by the public, right? So to compete in the A shares market, I believe the agents might not be just good at to do some emotional. So because the deep research analyze capacities of the agents will really add values to the markets. Right, because when we do some probably long-term investment probably we will do a lot of deep research and survey and to check the probably the financial report of the companies and to check how the future development of this company, and then we make the decisions for investment. Okay, so that will be very similar as the AI agents do. Okay, but I think another thing is for the crypto. It's totally different. For crypto, because the AI agents, probably is the times for AI agents to do the deep research and the analyze may take around 10 minutes, right? Because the AI agents will go through the internet to figure out some relevant of the financial reports to grab the key knowledge and insights, and then to generate and to conclude and to do the trade. Okay, so that will take that 10 minutes. But for the crypto, it's super dynamic. So 10 minutes for the crypto market is super long. So I think for the crypto market, the AI agents might not be a good fit. So it's super dynamic. So I think that probably will be our some key observations from the different markets with the AI agents. So you can continue to watch it, and so it's a live show. So we take the hourly update, and so feel free to give us some feedback and to help us to further improve these open source platforms for the AI agents. So I believe for the financial domains, I think if the deep research also will add some values, I think the AI agents probably will benefit the financial domains and to provide some more insightful and to helpful reports, and it can save a lot of time for the workers. Okay. And so for now, we have the AI will be benefit the artist and also financer. And then so we are thinking about problem, is that possible for AI to help our engineer, right? So I think that one of the representative domains which are significantly benefited by AI will be coding. So the vibe coding. Vibe coding means we would like to have our coding process to be more and more vibe and chill, right? I think most of our students in our group do not write code by themselves. They just write prompt. So code is cheap. Show me your prompt, right? So I think that will be the current, development of the coding agent. So I think that nowadays probably probably last year, I think most of the researchers and also the engineers might not believe that AI agents can do the code. But now, I think 1 year later, the AI agents now probably will generate the majority of the codes, right? So I think that will be totally different, within 1 year development. Okay, so we would like to say the coding agent is super important. Okay, so the vibe coding means you probably can only input your idea, and also the AI agents can help you to write a code for you. Okay, and then we have many, just some coding agents. We have I think most of you guys use Cursor, right? A Cursor probably will be a very good assistant to help you to write a code. But what might be the limitations for a Cursor, right? And I think nowadays, the right code, the problems will be the right code writing is not the final goal. Your final goal will be how to solve your challenges with code. So code will be your solution. It's not your final goal. And then now you have the Cursor. You can generate some codes, help you to address some challenges. But you have to summarize your generated code, and also to try to do, when you go to deploy some practical system, you have to finish some configurations, environmental setup, algorithm validation, right? And also evaluation, benchmark, and also you have to finish probably the rest of the percentage of the coding environment. I think that's my problems will be, take a lot of times. So I think nowadays I think a very, just interesting names for us will be the 大模型售后工程师, right? So 上后工程师, right? So I think the AI agents probably now Cursor will generate from the 0 to 80%. But you have to take care of the rest 20%. But the time spent on the 20% might not be short, might not be shorter compared with the first 80%. Yeah, because sometimes when you have to debug by yourself, you have to probably to validate the correctness of your algorithm by yourselves, and you have to just to configure and also to develop the entire infrastructure for your project. That may take a lot of time. So we are thinking about problem. Is that possible to use agentic coding and to generate a repo level code base instead of just some file level? I think nowadays the Cursor could have to generate some file level code, but I think if you would like to generate some code repo level, probably will just take a lot of additional supplementary capacities into the consideration. So we are thinking about the core components of the coding agent will be also the planning, memory, tool use, and multi-agent cooperation. So first, for the planning, means the AI agent should be able to decompose the task into different subtasks. And then probably will finish the different subtasks one by one. And for the memory, means the AI agent should understand the requirement and also the code base. And then they probably will manage the code context and relevant to your requirement. And also for a tool use, because probably the AI agent should decide which tool we should select and we should core, right? And finally, we have the different, because the coding process is complicated, we have the code generator, we also have the code validator. We also finally, we have some problems to evaluate the code. That will be super important. And also how to ensure the efficiency of the entire process. That will take a lot of time for the multi-agent cooperation. Okay, so that will be the motivations we deliver the deep code. Okay, So for our deep code, it's fully open source. Okay, for our deep code, we target three key objectives. So first, we would like to have a paper to code. Nowadays, we have so many papers, but only very few of them are open sourced. But when you try to reproduce the algorithm of the algorithm proposed in this paper, you might take more than 1 week or even a couple of weeks help you to reproduce. Right. So why we take a long time for a reproduce a paper algorithm? Because sometimes I think many details have been ignored in the draft, right? And also they have sometimes think, and also the authors might not would like to include some failure case in the draft. They only report the successful case. I think that's a problem, right? So, but how to when you have to reproduce the paper results, you have to just to do many a failure test and to probably do many tests and to spend a lot of time. So that would be our motivations. Is that possible to enable different researchers and students? When you input a paper, we deliver a fully runnable code base relevant to the algorithm proposed in this paper. Okay, so that will be our objective. Okay, so we deliver the deep code. Okay, so the deep code, how the deep code works. So first we have some planning parts. For the deep code, we have our planning means we try to understand the requirement input by the users. So we have our planning components. In our deep code, we try to decompose your requirement into some fine-grained and also some high-level summarization, which meet your requirement and relevant to the code base you would like to generate. So it's probably for this one, we build a high-level structure and conceptual mapping process, which can translate your ideas into some very detailed technical documents, right? Because sometimes the users may not always be familiar with the target domains, right? For example, if I would like to build some AI agents for medicine, I'm not an expert for medicine, but I only input my requirement. So the AI agent should be able to retrieve some technical details relevant to some medicine domains and to enrich my context and to enrich my intent so that should be the responsibilities of the AI agents. Okay, so for the low-level technique, probably I think for the AI agents, for the deep code, so we have some very detailed and fine-grained requirement for the low-level code understanding, and then we also have some high-level because sometimes for the algorithm it's including some high-level algorithm and also some low-level implementation. I think that would be the key challenges for the deep code. Right. So, and we also build our code rack system because sometimes if you have a very strong foundation model help you to generate your code, okay, so you probably will rely on a crowd code to generate the code file for each file. But sometimes that's super expensive. But if we rely on some open sourced model like a Chain1, like DeepSeek, the weaker the model, the more important the rack system and the memory system will be for how to manage the context. Okay, so for the code rack system, so which we build the index system and to relevant to the different code. And so in our system, we try to you can input your repo, and we can build an index system for your repo, and you can chat with your properties will be understand the context relevant to your repo. Because I think sometimes for a coding process, the code modality is different from the text modality. For a code, how to generate the dependencies, interdependencies, and correlations across different class, across different functions might be the key for the coding agent. Because sometimes I think for the context understanding is super challenging for a human to fully understand the context across different code files. But for the AI agents, they can, because they have a very comprehensive indexing system, which might reflect the interdependencies across different files. Okay, so but actually in our practical scenarios, we are working. Most of us will work on some complicated code project instead of just one code file. Okay, so that will be our practical requirement for it. And also we have some like a memory system. We try to do some very efficient and effective context management. And one very important component for the code generation will be the verification. Because sometimes our objective is to deliver some runnable, reliable, and correct code base. Means for each step, we have to do the verification. Right? Otherwise, we have some error. The error will propagate to the final results. So it's different, totally different from your expectations for that. Okay, so that will be very important. And for each component, for the memory, for the planning, we add some verification layer into the deep code system. Okay, so and we also to try to implicit like some different tools into a very easy to use function, and you can use the different like tools in your coding agent. And our deep code is a multi-agent architecture, and we have different we have many specialized agents to understand your intent, and also to parse the documents and to plan the code, decompose the different tasks. And also we try to just to index the code with some RAG techniques. And finally we generate the code and evaluate the code and to deliver some just some repo level code base for you to use. Okay, so that would be our deep code framework design. And finally we have our evaluation to how to evaluate the performance of the deep code. Because for deep code we are targets the domain probably is one of the most important function for and feature for deep code will be the paper to code. We try to check and try to evaluate the performance of the deep code and probably across in our some representative benchmark for the paper bench. So the benchmark is try to reproduce 20 ICML top AI conferences papers into some real implementations. Okay, so we compete with Cursor. We compete with different coding models, and we also compete with some 8 machine learning PhD students from Berkeley, from SMU, from Stanford, from Yale. Okay, we try to check the performance. Okay, and we can see that now the coding probably the deep code will beat the different coding agent like Cursor, and I think very interesting observations from the results means that deep code now also beat the top PhD students, machine learning PhD students. And also the PhD students are allowed to use Cursor in their computation. So I think the problem is how to, just to manage the very diverse and complicated context in the coding environment is very important, right? So that, I think all the eventual results has also been fully open sourced in our GitHub repo. Okay, so this will be, we also have a demo for a deep code. I think the one key important things for the coding, because now, I think before we spent much time to write a code. Now we spend much time write prompt. But for me, I don't want to spend time to write a prompt even more. So we expect our AI agents, coding agent, to fully understand us, to help us to write the prompt. Right. So I think the final goals we are towards is to the users can only input a very vague, intent, and then the AI agents can help you to write the prompt and then to write a code and to deliver the final results for that. Okay. And finally, I would like to introduce our recent works for the AI core scientist, AI researcher, because we are researchers. We are working on some spend most of our times to doing research. So we are thinking about problem. Is that possible to replace the advisor as a researcher, right? So, but after our evaluation, we say, okay, so it's kind, yeah. So for the doing research, so probably we have several key stages for doing research. So first, we probably need to do some comprehensive literature review, to do a deep survey, and to by reading and understanding a lot of papers, right? And from probably from different resources from different libraries. Okay, then we need to come up with some very novel ideas and towards some topics. Okay, so this stage may take a couple of months. Okay, so then we go from idea stage and to the implementation stage. We should to propose your new algorithm and to implement
the algorithm, and then validate the algorithm, do the experiment. Okay, so this also may take like half a year. And but I think nowadays, writing a paper might be the easiest component in the research process, right? Okay, so I think the literature review, idea generation, and also the algorithm validation design may take, probably will dominate the time for doing research. So now since we release our LOVIX as a core scientist. So the purpose of the LOVIX as an AI researcher is not to replace the human researcher. So we would like to free the human researchers from the repetitive tasks, repetitive like different jobs, and we would like to have the researchers to be more focused on the innovation. Okay, so for our AI core scientist, we have like different features. We have a deep survey, help you to probably to fully understand the domains, especially for if I'm a beginner for some domains, might need a deep survey, help us to grab probably the context for relevant to the deep, for different research lines. And then the AI researcher, AI core scientist system will help you to come up with some cool ideas and relevant to the probably will be the domain, and then help you to do the experiments and can also do some data scientist for you. Okay, so here will be some demos for, so you can say, so when you can input your requirement. So the LOVIX will help you to, just to write a very comprehensive technique summarization and also the deep survey relevant to your expected domains, right? So that may take you a lot of time because I think sometimes probably the literature review and summarization may, will be dominate the first stage of our, of our research process. And I think another thing is that I think the key challenges for the doing deep survey is the content itself. Because now LLM can also generate the report, but how to make your generated the report content to be valuable and insightful for you to, to refer to. So we would like to include more 干货, right? In the report. It's not very vague and high level, right? So nowadays, when you use deep research, you can say probably the deep research will go through the internet, but we have, just much of the information will be the noisy signals, right? So, and you can have a report, but it seems like the report may include many redundant content, and also, just might not be, will be very high level, might not be very deep. But for doing research, we need some very deep understanding for the for the domains. And also, after we have our deep survey, the AI core scientist system will help you to generate a ideal flow relevant to your domains. And you can say it's very the system will summarize, help you summarize the development and also the state of the art relevant to the one specific line and into different subdomains, and even from a high level to fine-grained ideas. And then you can pick up probably one idea and it goes to design the methods. And then the AI core scientist will help you to write the code, help you to validate the code, do the experiments, to pick up the benchmark, to pick up the data set which might be more appropriate for your domains, and help you to run your experiments and across different just dimensions, to help you to probably to do the comparison with your selected baselines, to help you probably will be just to do some different domains of experiment with some ablation study, efficiency study, and also to check probably will be to check how to position your algorithms in these domains. Okay, so that would be the system. Okay, and here will be some. Also, we have the domain, and you can check probably this video, and yeah, and also we try to, and in our experiment, we also, just to evaluate the end-to-end research capacities of our AI core scientists. And so we generate 20 papers. So for those 20 papers, they are fully generated by AI, means there is no human interaction during the research process. Okay, but we are not submitting the papers to a conference. We are just open source the papers to GitHub. Because nowadays, I think AI conferences might be a little bit, just sensitive for the content submission fully generated by AI. So you can check, right? So our AI scientist system work on like 5 domains, including CV, from CV to NLP, to data mining, to graph learning, and to some recommender systems. So the AI agents, the only input from the user is like 2 or 3 reference papers. It's like an advisor, right? The advisor always sends students, okay, so here are 5 reference papers. Go through, go ahead with your research. Okay, so then the AI research system Novix just try to follow your input, like several reference paper, and to try to do the literature review, and also come up with like 5 or 10 ideas, and to go to the algorithm design, algorithm validation, implementation, and also to finish all the experiments and to write a paper. You can check the paper, and all the derivation details has been included in the papers. Okay, so it's like a, also for the papers, and you can check like, so we just use the template of the iClear. And we also do some validation for how the papers, how the probably the quality of the papers. And we make comparison with AI generated papers with some human generated papers. So because the objective of the design some AI core scientists, because we would like to pursue the high quality research. So we are target some high quality papers and impact papers from different like conference like Europe's ISML or iClear. Okay, so we pick up the papers with more than 100 citations after 1 year as a target paper, because we believe those papers might be high quality papers has been validated by the community, right? And the percentage for such impact for research paper is only like less than probably less than like only 1%, right? For all the accepted papers for the conference. Okay, so after our experiment, we figure out that now the AI capacity probably will be equivalent to the probably 30% of the human intelligence with some high impact and also some high quality papers. So we still have some rooms, right? So how to improve. Okay, so you can check this code. So this code is totally generated by AI. So there is no human input into the process. Okay, so we have like some papers and input and for different like domains. And I think that for the purpose of the AI researcher, and also the AI researcher is fully open source on GitHub. You can play with it. And we also build some real production level system, Novix, and for human to easily use. And we try to, we make significant efforts to try to reduce the cost and try to optimize the system and to make it more no cost and also efficient. Okay, so I think the motivation of the design, the AI core scientist is not to encourage the student to use AI to generate the papers, right? I think the themes the objective is to speed up the research process. So think about probably when you're doing research, you probably might spend like 1 month to try one algorithm, right? To check it, is that reasonable? Is that make sense, right? But now with AI, you probably can try 100 algorithms within 1 week. So this will significantly to speed up and facilitate our research process, and also free the researchers from some repetitive tasks and into the architecture design and also the innovation idea proposed. So then how to do the experiment, how to do some repetitive tasks, we should to give this job to the AI, right? So I think that will be our objective of the design the AI research and also to do some like AI core scientist. So that's the reasons why we call it like AI core scientist, because we would like to encourage like human researchers work with AI to deliver even higher quality of the research. It's not just to blend it to generate the papers. Okay, so that will be all the content I delivered today, and I would like to give the credits to our team. So I feel very fortunate to work with such a passionate teams, and thanks to them. And so I would like to give all the credits to the team. Okay, so thank you so much for your attendance, and hope we will have some further discussion. Thank you.
Very impressive that in just a few months that Professor Huang has a lot of more progress compared to the last time. So yeah, I have a simple question for Professor Huang. So do you even sleep?
Yeah, I think I will sleep, but my student never sleep.
You have your co-scientist as well.
Yeah.
Okay. So any question from the audience? Yeah. Yeah.
Yeah, I was.
So first, thank you so much for delivering the talk, and the work are very impressive, especially for the deep code and also the novice. And I want to know that inside your lab, within your lab, when will you use the tools developed by yourself? When will you use the commercial tools like Cursor? And when will you write the code or write the paper yourself manually?
Okay, yeah, that's a very good question. So to be honest, in our group members, we use AI tools as much as possible. Yeah, especially for some repetitive tasks. But I think the human also should take the responsibility to check the results, because the AI will not take the responsibility. So the human will take the responsibility. I think for the ideas, so how we come up with some ideas to do the agents, because I think that will be our key challenges in our daily use. So for the properties, so why we develop some deep code, because when we use Cursor, we figure out some limitations for the Cursor, but we try to make our coding process to be more and more vibe. So we propose a deep code. We try to properties will be, just to reduce the cost for the human, to fix the bug for the AI generated code, and also to do some other rest of the task. So that will be our properties. I think that all the motivation come from our practical experience. Yeah.
Thank you for your talk, very impressive.
Thank you.
And about the AI trader, I think the POM is very sensitive to the performance, because I test many different POM in your project. And second question is, if you use deep code, if you need to use API call, will it be so expensive to do repetitive iteration?
Yeah, that's a very good question. I think so. For the cost, so it's very important for the coding agent. So in our deep code, so actually our foundation model is a set. It's not only individual, like some model, so we have a set. So when to use so we try to reduce the cost. We try to use some like more effective and lower cost like models, and to enable our deep code. But I think for the coding agent, so the weaker the foundation model, the more work we should to do in the context management, right? So for example, if we rely on the crowd for 0.5, it's a very stronger model, right? So then you will deliver some very complicated algorithm implementation, right, with some very strong model. But if you target probably some like a not very like a state-of-the-art algorithm implementation, we might rely on some more like a cheaper like a frameworks and with some model like a Chain1, right? So it still works. But to integrate and work well with Chain1, I think code rack and also the code memory is very important. Yeah, it seems like if the model itself can generate the code better than GitHub, you can rely on the model to generate code. If the capacity of the model is weaker compared with the GitHub, we should refer to the GitHub to have the better implementation. So that would be the logic. Yeah.
Okay, other questions?
Hello, Professor. I think that I have a question about the model training and the data sets, because I think this is sometimes we will associate with multi-agents. So how can we get the data and how can we train those models? And these details, I want to learn something about it.
Okay, yeah, that's also a very good question. So for model training, so I
I only encourage a student to do the training process of the models if you target a very domain-specific, like some problems will be very targeted, like the medicine or chemistry or materials. So then you probably, I think, how you prepare the data for training. So my suggestion is to leverage the advanced, like commercial models to be your data labeler. And then you have your data labeled with the commercial like models. And then you can probably distill the capacity of some commercial models and from some very strong models and to your trained models. But I think this process you can, so actually it will be resolve a good question like how to, just the relationship between a foundation model and the agents. So I would like to say the agents is always, the agents should be stronger compared with the foundation models. Then the agents can help the foundation model to produce some data, to generate some data. Then we can use the data to train the foundation models. And then the foundation models become stronger. And the agents should become even more stronger to generate more data. Yeah, because for example, if the foundation model can only chat, and we can have some agent system can help your foundation model to core the tools. And then we should to train the tools to core capacities into the foundation model. And then we should have the agent to be more, just a more intelligent to finish a more complicated task. And then we just do this iteratively, right? So I think that will be the paradigm and frameworks how to, just to the relationship between the foundation model and the agents.
Okay, thank you.
Thank you.
Thank you, Professor Huang, for this very insightful and informative talk. There are really a lot of products. So I have two questions. One is related to the trader, and one is related to the researcher. So for the trader, I'm curious, do you also do stock derivatives, like warrants and those sort of other derivatives from stocks in your AI agents? And the second one is more of an in-depth question, which is from my personal knowledge, doing research sometimes means finding some what previous methods have overlooked and sort of gain insight from that.
Yes.
And so how can, since AI sort of learn from pre-existing information, how could you actually generate new insights from previous knowledge that have been missed that was not mentioned in any form of way before?
Okay. Yeah, thanks for the question. So to answer your first question, so for our AI trader, there is no human interference. So each decision will be made by the AI, means so we only provide the available tools to use for the agents. So whether and when to use the tools is determined by the AI itself. So in this way, AI trader is only a fully automated system. So I think your suggestion is very useful because we are not an expert for finance. So I think if we can just to integrate more advanced tools which can further benefit the trading decision, that would be more helpful. So I think now the community are actively working on contribute to the AI trader and to make it more and more, just to practical use for the trading. Yeah. But so nowadays the results and suggestions provided by the AI is only for your references. Okay. To answer your second question, because I think for the AI trader, your observation is very good. Yeah, because I think for doing some novel breakthrough and research, sometimes we need to correlate some unrelated items. But those unrelated items has not been reflected in some existing knowledge. I think that will bring the challenges for some our the knowledge indexing system. Yeah, because I think for our AI core scientists, we build a knowledge indexing system, right? So it's you can consider it like a logic graph. Logic graph means we probably have some knowledge entities. We have some relationships. We try to build some implicit and also explicit relationships among different entities. So if we can somehow to reflect such like a interdependencies across different entities, like probably one entity from medicine, one from AI, and one from materials, one from chemistry. So if we can somehow to mining some potential relationships from those entities, that will bring some new innovation ideas in our AI core scientist. But I think for the AI, if we just fully rely on AI to do the innovation breakthrough, that might be limited at this stage. So yeah.
I see. Thank you very much.
Okay, other questions from the audience here? Oh.
Hi, Professor. Actually, I'm curious about if I use the large language model such as ChatGPT to help me write an essay, it may have the hallucination about the reference.
Yes.
Yes. So for the video, for your project video understanding, so how to like because the input video is really has a long time for those videos. So if the in the chat, how can the user, for example, how can to check if the model to give me some hallucination, because there are so many frames, it's really hard for users to check the information from the videos frame one by one.
Yes.
So that there have any like the solutions or methods to validation the knowledge.
Yes, yeah, that's very important, especially for the references. So we should to enable the correctness of the references. So in our AI core scientist properties, we add a validation agent. So the agent will go through each references and to search is that really is a real references and from the Google Scholar and to validate it. So I think that properties will be a useful way to validate the correctness of the references. But for some methodology, I think sometimes I think the hallucination cannot be fully addressed. So we have to just to make our efforts to address and to reduce hallucination as much as possible. So I think for the doing research, especially for the AI and coding, so we may probably will to look at the results, right? So if the AI can design some results which performs good on some benchmark, and also some can make comparison between some existing methods. So with them, so we probably will to take a look at the details to say which components really works. So it's not like a process we use AI to generate results and then submit. So we should probably, I think, use AI as a helper to help us to validate the results and to impair. It's not like to help to generate results by human. I think that probably will be the key points for AI as a core scientist.
Yeah, but for the video understanding.
Video understanding.
Yes. So it's hard for users to check the information.
Yes. I see.
Yes. So how it's not like the it's not like the co-researcher.
I see.
Because user can check the ideas by some experiments, but
yes.
But for the video understanding, the user may need to check the video from the beginning. So
I think that's a very good question. So the answer actually is hard to check. It's hard to check the content from the video, especially for the visual content, because we cannot go to the detailed specific frame and to check. So I think sometimes I think for a video understanding, so if you target some summarized information, I think probably there is no ground truth. It's only a summarized. So it's an open-ended question. I think for this one, you probably can rely on the video understanding techniques for help you to do the summarize. Right? But if you would like to check the very detailed and also have some ground truth information, I think somehow the human have to do the double check. Right?
Thank you.
Thank you, Professor Huang, for such a great talk, and your work is very impressive. So I have one question. So you just presented, different agents, like the agent can do stock investments, or the agent can help do scientific research. So I'm thinking about, so would that be, or are you have something in mind, like in the future we maybe have a
a single agent which can sort of incorporate all these abilities, and this can allow us to sort of interact with this agent, and we don't have to, like, say, let's do stock investment, and I need to go to the stock investment agent, and if I want to do scientific research. So do you think this will be feasible in the near future, or is there any basic limitations such that we have to sort of kind of do this division of labor thing? We sort of specialize in a task specifically, and then we do another, and etc. Yeah, thank you.
I see. Yeah, thanks for the question. So I think you are expect a super agent can do everything. Probably even can help you to do the research, and also help you can make money by help you to do the training. So I think whether we should to go from one agent or multi-agent, so I think it depends on the cost. So for the users, I think a user might not care too much for whether it's a single agent or multi-agent. The user only care about the results. Right. So I think how to design your agent within one unified agentic framework or multi-agent cooperation depends on the cost and the performance. I think nowadays, because like the model cost is super high, so sometimes we have to design some multi-agent in order to reduce the cost. And also sometimes because I think for the human, sometimes for like doing research, we are a team. We may take different roles. I think that might be straightforward if we design some multi-agent and to take care of the different roles for doing some research or doing some trading process. So I think there is no ground truth whether we should go from one agent or multi-agent. So it depends on the cost and also the performance and also some domains. I think currently for the agents, so the generalization capacity of the agent has not been fully explored compared with the research on large language models. Because sometimes for different domains like medicine, finance, you have your own like private data. So such data might not be available and public to the agents. Sometimes I think only domain expert may have access to such data. That brings the challenges to design some generalized agents can perform good across different tasks. So I think that might be the bottleneck for the building some very super agent across different domains. Yeah.
Okay, other questions? So we still have some questions on the web. So if you don't mind, you can answer some of the questions.
Yeah,
quickly.
No problem.
Yeah. The first question, do special purpose AI agents have a catastrophic forgetting problem? So when a market shock hits, how to stop a system crash like cat attack caused by unrelated data, and do humans step in to push a manual reset button?
Yeah, I think how to, the forgetting problem for agents, I think it depends on the context management. So if we have, we can manage the context in an effective way, somehow we can try to enable the agents can memorize some long context signals from the from the previous steps. So it's like, so it depends on, I think that the memory, nowadays the memory problem somehow can address some challenges for the forgetting problems and issues.
Okay, yeah. So the last question. Currently many research projects try to develop end-to-end training system for multi-agent systems. However, it seems like most applications use API orchestration. So for a researcher new to this area, which kind of research on AI agent should we opt for?
Okay, I think if you are target a very general agent, I believe some probably it's hard to especially for student and researcher to train your own model and to probably because we are lack of some computational source and data high quality data especially. But if you are target a very domain specific, I think probably somehow because you own your private data, I think somehow it's possible for the domain expert to train some specific domain, specific like agents which can help you to address the challenges in your domain. So it's probably case by case. So, yeah.
Yeah, that's great.
Yeah.
Thank you.
Yeah, thank you again for your attendance. Thank you.
Thanks for staying so late. Yeah.